Hey guys, this looks like a fun one. This girl's writing a guy saying, "How much do you love me?" And he responds at -1/12. What is he thinking? Why would he say -1/12? I feel like he should have said something like 1 plus 2 plus 3 plus 4 plus 5 plus 6 going on forever. I feel like that would have been a much more romantic thing to reply. I wonder why he didn't do something like this. Maybe because it's kind of confusing, the idea that it goes on forever. What value can you give to this? It's going to keep growing and growing and growing forever. This sum will not converge to a specific value. If it's not going to hit a specific value, we say it diverges. And it's pretty clear this will diverge. It's just going to keep growing forever. But for the fun of it, let's pretend it doesn't diverge. Let's give it a value x and let's figure out what is x. So we're going to assume it does have a value, and I'm going to try to figure out what would that value be. This is what we're trying to solve, so let's put a box around it. This whole idea of divergence is really interesting. It doesn't have to grow forever. It could oscillate as well. You could have something like 1 minus 1 plus 1 minus 1 plus 1 minus 1. Do you add these up? It's going to go 1, and then you'll have 0, and then you'll have 1, 0, 1, 0. It's going to keep alternating between 1 and 0. We also say that this diverges because it doesn't converge to a single number. But once again, let's pretend it doesn't diverge. Let's give it a specific value b, and let's find out what b would be. Let's mess around with it a little bit. Let's copy down the b on the left-hand side, and let's copy down the first term, the 1 on the right-hand side. But for the rest of it, let's factor out a -1. So this -1 will become +1. The +1 will become -1. This -1 will become +1. This +1 will become -1. And that pattern will continue forever. All we did was factor a negative out of the rest of these infinite terms. So now we have b is equal to 1 minus all of this inside of the parentheses. This is how we defined b. Inside the parentheses, we can change into b. And now we have b is equal to 1 minus b. From here, we can add b to both sides of the equation. And that'll give us 2b is equal to 1. Well, let's divide both sides by 2. 2b divided by 2 is b, and 1 divided by 2 is 1/2. And now we have our value for b. We can change it into 1/2. We know this series will not converge, but if it did converge, it would converge to 1/2. And another way to think of it is it oscillates from 1 to 0 to 1 to 0 to 1 to 0 going on forever. And the average of 1 and 0 is 1/2. Once again, I feel like emphasizing this is not equal to 1/2. It's just that if it did converge, the math says it's equal to 1/2. Now let's try one that's kind of a combination of both of these. 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on. This will also diverge. It'll go from a large negative to a large positive to a large negative to a large positive going on forever. It won't converge to a single number, it diverges. But for the fun of it, let's pretend it doesn't diverge and let's set it equal to something, let's say c. And let's figure out what c would equal. Let's copy down the c and let's copy it down one more time. If we scoot this over and put a 0 in here, nothing has changed. And to make this look nicer, let's continue the pattern. Let's put in a +7. Now, what would happen if we added the two c's together? On the left-hand side, c plus c is equal to 2c. And on the right-hand side, we can add up all these pairs. 1 plus 0 is 1. -2 plus 1 is -1. +3 minus 2 is +1. -4 plus 3 is -1. 5 minus 4 is +1. -6 plus 5 is -1. 7 minus 6 is +1, and this pattern is going to continue forever. So 2c is equal to 1 minus 1 plus 1 minus 1 plus 1 minus 1 going on forever. We already figured this out earlier. This is our b, so we can change all of this into b. And this, since we're assuming none of these diverge, we have a value of b of 1/2. So let's plug in a half for the b. And now to solve for the c, let's divide both sides by 2. On the left-hand side, we'll have c, and on the right-hand side, 1/2 divided by 2 is 1/4. And now we have a value for c. If this infinite series converged, it would equal 1/4. That's pretty cool. Let's see if we can figure out the x now. Let's copy this down here. How would we figure out what this x would equal? Let's see if we can use these at all. I don't know if this is going to do much, but I think we can do something with the c. Let's subtract the c from the x. On the left-hand side, we'll have the x minus c, and on the right-hand side, we can subtract each of these pairs. 1 minus 1 is 0. 2 minus -2 would be 2 plus 2, and that equals 4. Positive 3 minus positive 3 would give us 0. 4 minus negative 4 would give us 8. 5 minus 5 would give us 0. And the 6 minus negative 6 would be 6 plus 6, which is equal to 12. And this pattern will continue forever. So it looks like every other one is a 0, and these are increasing by 4 each time. Let's get rid of all the zeros, smush all these together, and put them in parentheses. Everything in the parentheses will have a factor of 4, so let's factor out that 4. And after we factor out the 4, let's figure out what's on the inside. 4 times what gives us 4? Well, that's 1. And then we're going to add 4 times what gives us 8. That's 2. And then we're going to add 4 times what gives us 12. That's 3. And this will go on forever. It'll be 1 plus 2 plus 3 plus 4 plus 5 and so on. Now this is pretty cool. The 1 plus 2 plus 3 plus 4 plus 5, that's our original sum. That's what we're calling x. So in the place of this series in the parentheses, we can plug in x. And now we have x minus c is equal to 4x. Now let's get all the x's to the same side of the equation. Let's subtract x from both sides. On the left-hand side, we'll have negative c, and on the right-hand side, 4x minus x is 3x. Next, we can divide both sides by 3, and we have x is equal to negative c over 3. Earlier with our assumptions, we found that c is equal to 1/4. So let's plug in 1/4 for the c. And then negative 1/4 divided by 3 is negative 1/12. So we end up with x is equal to negative 1/12. This is so interesting. So if we ignore the fact that this obviously diverges and keeps growing forever and assume that it converges, the math tells us that this sum would equal negative 1/12. And now I understand what this guy was trying to say. He was trying to tell her that he loves her 1 plus 2 plus 3 plus 4 plus 5 plus 6 going on forever. How exciting.